Hi everyone, today we can talk about tangent and normal lines. So this topic will always come out in SPM, okay? So they always ask you to find tangent line as well as normal line or some hidden information in the question that refers to tangent and normal. Okay, so let's do some exercise. So first of all, you need to know what does dy dx means. So previously we have learned how to find dy dx, right? We have to know how to find dy dx by using product rule, quotient rule, and also chain rule. Okay. Now, what does dy dx actually means? Okay, so if you have an original function y equals fx, then on the graph it will look like a curve like this. Okay, so you can sketch that out. So f3, what does it mean? It's just like, let's say 3 is here, then f3 means the value of that at 3, right? So it will be somewhere here, and this one will be f3. The height will be f3, which is the number. Okay, so f3, the number there, means the height at x equals 3. Okay, then now the derivative dy dx, or when it's given in terms of fx, then you say is f prime of x is then this one. So now dy dx at x equals 3 or f prime of 3, that one, what does it mean? So now let's say here you have like a tangent line here. You have a tangent line, let's say here. You have a tangent line, let's say here. You know what's a tangent line? Okay, so this is a tangent line to this point. This is a tangent line to this point. So now f prime of 3 actually means what? Actually means that the slope or gradient of the tangent line at x equals 3. So from here, you see, if you drop a tangent line at this 3 here, okay, then this is called the tangent line at x equals 3. Okay, so what does dy dx when x equals 3 means? It means the slope. So if you want to find the slope for this one, you find f prime and you substitute 3, and that's your slope. Okay, so you understand that? So this is very important here. Okay, this one very important. So f prime 3 is the slope or gradient of the tangent line to the curve at x equals 3. So now you know what does it mean by dy dx when you substitute a number. And you know, like let's say your fx is equal to 2x, the differential is equal to 2. So that thing 2 is just the slope. You can substitute number in, right? Okay, let's say fx equal 5x squared, differential is 10x. So you substitute a number in, it will give you a number. That number is the slope. Okay, right. Let's move on to talk about something else. So find an equation of a tangent line at the point 1 and -2 to the curve y equals x squared minus 3. So now graph is given here. Okay, graph is given here, and you have the point 1 and -2 here. So now what do you need to find? You want to find an equation of tangent line. Tangent line should look like this one, right? Okay, move across here. Okay, touching here. Okay, that's tangent line. So how do you find that tangent line? First of all, you need to know the slope of the line, right, before you find the line. So how do we find the slope for the tangent line? So it's just dy dx. dy dx is equal to 2x. Then at which point? At a point x equals to 1, y equals to -2. So you only need this information, the x information. The y is not needed. Okay, then sub the 1 into there. Then dy dx you get 2. Okay, what is 2 here? 2 means the slope of this tangent line. Okay, it's the slope of the tangent line. This is typo. It's the slope of the tangent line. Okay, slope of tangent line, m is equal to 2. Okay, so y will be equal to 2x plus c. Why is that so? You've learned this in chapter 6, right? Okay, so slope is given, m is given, so y is equal to mx plus c. Mx plus c, your slope is 2, so it's 2x plus c. Then how do I find the c here? You have a coordinate here. This coordinate you sub into x and y, then you can find c. Okay, I sub x equal 1, y equal -2 into that equation, then I'll find c. And hence c will be -4. And after I sub it back into this equation, then I'll get this as my final equation, the equation of a line, 2x minus 4. So where do you draw that line? It's here, this line here, and this line is 2x minus 4. Okay, slope is 2. Correct? Great. Okay, tangent and normal lines. So if you have this one, tangent line, I guess you know how to draw already. It's this one, right? So I call that tangent line LT. Okay, tangent line to the curve at PHK. So normally you just need to know the x value, then it's sufficient. Okay, how about normal line? Normal line is the line that is like chopped into the cake or chopped into the curve, then it's perpendicular to the tangent line. Okay, so you see this and this, they are perpendicular. So normal line and tangent line, they are perpendicular. Perpendicular, so this is normal line. Okay, so this is normal line. First of all, you know what's a normal line, right? Okay, normal line is always perpendicular to the curve. Okay, or you say normal to the curve. Okay, that's the commonly used word. All right, so now if I call that one tangent line as LT and normal line as LN, and they have slope MT and MN, then what do you have? What's the relationship between MT and MN? They are perpendicular. Perpendicular lines, if you have M1 and M2, what's the relationship between them? M1 times M2 has to be equal to -1. That's why you have MT times MN is equal to -1. Okay, no problem with this. All right, so this is the condition that you have since they are perpendicular, or you say normal. Great. Okay, let's move on. So now find the equation of a normal line. Okay, so tangent line, you have done it before already. The answer is there. So now we don't want tangent line anymore. We don't want this anymore. Now we find normal. Let's say we find normal line. Then, okay, to find equation of a normal line, you have this condition, correct? Because they are perpendicular. Perpendicular, you have this condition. And now, you know previously m is equal to 2. Hence, you substitute 2 into mt, and you get 2mn is equal to -1. Hence, mn is equal to -102. If you get this slope, what do you need to find the line? A slope and a coordinate. You have a slope and coordinate. Why? Because let's say this is a curve, this is a point, tangent line and normal line, they share the same coordinate, right? Okay, they share the same coordinate. So this one still can be used. Okay, then what do you do? Y is equal to -12 x plus c. Okay, then what do you do to find c? You sub this point into that, and I'll get c. Okay, c is this one. So you get c is equal to -302. Okay, the equation of normal line, 1 and -2, is this thing. Okay, sorry, you get this, all right? Okay, no problem. Let's move on. Okay, so you have a curve intersects the x-axis. X-axis means what? Y equals 0. Okay, at the point P and Q. Find the coordinate of P and Q. Okay, and find the gradient of the tangent line at the point P and Q. Okay, so if you can try to do this. Answer is given here. Okay, right? If not, I'll try this. Okay, find the coordinate of P and Q. First of all, you need to know this one, P and Q, are the intersection points between this curve and the x-axis. X-axis, just now I told you already, is y equals 0. Okay, so this one, I'm equating these two, so it's 2x squared minus 3x minus 2 is equal to 0. So you simplify, or you put the cross there, then you try it out. So it's 2 and 1 and 1 and -2. So -4, -3. Okay, so 2x plus 1, x minus 2 is equal to 0. So x is equal to -1/2, and or x is equal to 2. When x is equal to -1/2, then I sub it back to here. Okay, when I sub it back to here. Actually, you don't have to sub it back to here, because you can sub it back to here or sub it back to here, because they are the intersection point. Okay, so if I sub it back to here, nothing I need to do. So y is equal to 0. So I sub it back to here. Of course, y is equal to 0. Okay, don't need to do so much thing. If you don't believe me, you can try. 2, you put it here, is 2 times 4 is 8. 8 minus 6 minus 2. So it's 0. So you get 0. Okay, so these are coordinates. So since there is no condition on P and Q, you can name anyone to be P, anyone to be Q. So maybe I just put this here. P, I wrote it 2, 0, so I write the same thing here. 2, 0, this is P, and Q to be equals to -half and 0. Okay, anyway, you can interchange the p and q. It doesn't matter because it doesn't say anything here. Okay, so let's say it says that the x coordinate of p has to be bigger than 0, then this one must be the p. Okay, let's say something like that. Okay, next, find the gradient of the tangent at the point p and q. Okay, so this is given, this is the answer, right? Okay, this is the answer. Find the gradient of the tangent at the point p and q. So just now we found that x is negative half and x is equal to 2. So x is equal to negative half and x is equal to 2. So just now this was p and this was q. Okay, just for my own reference. So then what do you need to do now is to find the gradient. Gradient means you find dy dx, which is equals to 4x minus 3. Okay, so you substitute this one here. So dy dx equals to 4 times negative half. 4 times negative half, then minus 3. So this one will give me what? Negative 2 minus 3, so minus 5. So this is for point just now q. Okay, the next one. Dy dx is equals to what? 4 times 2 minus 3. So this one also 5. So this is for point P. So normally I have to write this when x equals to negative 1 over 2, dy dx is this. Okay, so it's clear. When x equals to 2, dy dx is equal to this. Okay, then I'll get mp is equals to 5, mq also equals to 5. The q wrote it wrongly, sorry, mq is also equal to 5. Hence the answer here. Wait, mq is negative 5, okay? Not also, okay? They are different. Okay, one is negative 5, one is positive 5, right? Okay, have any problem with this? Okay, because gradient, what does it mean? Gradient is just a fancy name for dy dx. Okay, then that's it. All right. Okay, I think you can try this yourself. Okay, pause the video and try this yourself. Okay, we'll come back to discuss the answer. All right. So the gradient function of a curve is given by this. The tangent to the curve at the point 2 and negative 6 is parallel to the line. What does it mean by parallel to the line? Means they have the same slope. dy dx is the same as m negative 8. Okay, this is the slope. Okay, so right, let's do this question A. Okay, when x is equal to dy dx, the gradient. Okay, the gradient is given already. The gradient function is dy dx. Gradient function, it actually means dy dx if you want to write down. Okay, so dy dx, you sub 2 inside, so you get this one. Okay, then what do you get? You get 4a minus 12. Okay, so it's parallel to this one, so you have to equate to negative 8 because y is equals to mx plus c. This is how we extract the information about the slope. Okay, so you get that one. Hence, 4a is equal to 4, a is equal to 1. And you get your a here. Okay, no problem? Great. Okay, move on. Next one. Find the equation of the normal line to the curve at 2 and negative 6. Okay, 2 and negative 6. So, slope of tangent is negative 8. Okay, slope of tangent is negative 8. You know already. And slope of normal is what? Don't know. Then we use that. And 1 times m2 is equal to negative 1. And hence, m2 is equal to 1 over 8. After I get the slope, what do? I have to find c. How do I find c? I sub 2 and negative 6 to find c. Okay, then I found c. c is negative 25 over 8. And the answer is 1 over 8 x minus 25 over 8. Okay, right? All right. Next, the gradient of tangent to the curve, this one, at the point, this one, is 13. dy dx when x equals 1 is 13. Find the values of a and b. Okay, first of all, dy dx, you from here, differentiate, get tan x plus a. Tan x plus a. You substitute 1, you get 13. You substitute 1 here, you get 13. Okay, 13 is equal to this. So you get one equation. The equation is a is equal to 3. So you are done finding a. Okay, you are done finding a. Okay, next. This is an equation of this one. Except now, you substitute this 3 into here already. Okay, 3 into the function already. Okay, but you are left with b. What do you need to do? This one, tangent at the point, this one is 13. Meaning that this point is on the curve itself. On the curve itself means that you can sub this point into here and find b. Okay, you sub x equal 1, y equal 10 to find b. This is a hidden information because it says tangent to the curve right at that point. So that point is definitely a point on the curve right. Okay, since it's a point on the curve, so you can sub that point or coordinate into the curve and find the remaining variable. Right? So 10 is equal to 5 times 1 square plus 3 times 1 plus b. Hence you can solve for this. b is just equals to 2. Okay? 5 plus 3 is 8. So minus over is 2. Okay, get the answer? Okay, not very difficult, right? Okay, so these are all the things that might be coming out for your SPM. Okay, so finding those variables are more likely to happen. Okay, right. It's homework time for you. And then, so answer is given here. So I hope you can do it. And try to do this because it's very important topic here. Okay, I'll see you next lesson. See you. Bye.